Hi everyone, thanks for joining us today. I welcome you all to another webinar and welcome to In Conversation with Stratview. In this session today, we will explore the innovation challenges and future outlook of sensing systems in composite manufacturing, along with growing adoption of AI in this space. I am Dhaval Dattani, your host for today's webinar on sensing systems for smart composite manufacturing. If we look at manufacturing across all industries today, whether it's automotive, aerospace, or even electronics, there is a clear shift towards automation, real time monitoring, and data driven decision making. And composite manufacturing is very much the part of this evolution. Now, if you look at how composite manufacturing has evolved, it's actually pretty interesting. We have spent years focusing on material, making it lighter, making it stronger, making it more efficient. But now the conversation is clearly shifted. It's not just about what we make, it's about how intelligently we make it. And that's exactly where sensing systems and AI are starting to change the game. To help us better understand this transformation, we have with us Dr. Nikos Pantelelis, Director at Synthesites. Dr. Pantelelis has been at the forefront of integrating sensing technologies into composite manufacturing and is a two-time JEC Innovation Awards finalist. Dr. Nikos received his MSc and PhD in mechanical engineering from National University of Athens. He has been working on intelligent monitoring and process control in composite materials production since 2001. After years in research and project management, in 2009 he founded Synthesites, which is now a leader in intelligent industrial process monitoring for composite production across aerospace, automotive, and wind energies. Nikos, it's great to have you with us today, and congratulations on being a finalist once again. How are you?
Thank you, Dawal, for the introduction. I'm fine. I hope the same for you.
I'm fine. I'm fine. It's quite hot in Raipur right now. We have the heat waves here.
Yeah,
So,
here in Brussels is quite nice.
it
Not so
seems
hot.
a bright sunny day there. Yeah.
Yes, it is.
So, Nikos, all dues done. I guess let's right away jump onto the business and have a discussion on composite manufacturing.
Yep.
So, uh, I would like to know, as a two-time finalist in JEC Innovation Awards, what do you see as the drivers for innovation in composite market today? Like, what are the investors expecting? What are the OEMs strategic decision on composite manufacturing? Could you please help us with that and share your industry knowledge with us?
Sure. Thank you for the interesting question. As you mentioned, we are already two times finalists in JEC Innovation Awards, which are highly respected in the composite community
Definitely.
worldwide. And I would say that we are mainly working with OEMs, manufacturing OEMs, because it seems that OEMs are desperately looking for innovations in smart manufacturing. They need tools and help in order to optimize their processes, and so they can find some good, let's say, solutions in the technologies that we are providing. As you may know, we are very much focused on industrial. use of our systems, not so much in the laboratory scale applications. So we are working in partnership with OEMs in order to help them to improve their processes and increase their productivity.
Okay, okay. So the industries, like you mentioned, more into industrial. So basically, aerospace, wind energy are the prime markets for now. They are going crazy. They have good, decent growths over the years and are expected to have decent growths uh, ahead. Like you said, it is somewhat industry dependent as well, the innovations and stuff. And industrial is doing great. So, just stretching this question out, like, could you share more details on the core breakthrough or innovation that led to the JEC Innovation Awards of yours? Yeah.
Well, our innovations are really focused on providing robust and intelligent sensors and sensing systems for composite manufacturing. As you mentioned, aerospace and wind energy is one of the markets that are really booming, and they are really looking for to use our technologies in improving their manufacturing performance. This is very important for composites because, as you may know, composites are very resource intensive, time intensive, cost intensive. So all the our technology can help manufacturers to reduce processing time, to improve quality, to reduce, for example, defects, to reduce scrap and all this. So this leads to innovations in composite
Okay.
manufacturing, and that's what we are trying to support towards the industry.
Okay, got that. Got that. So, while checking about synthesites, I discovered that the innovations around resin infused process manufacturing was done, like RTM, high speed performance, and all was done. So, just to have a brief overview about composite manufacturing, I would like to share one slide with our viewers and you that indicates the total market of composite material, how the manufacturing processes are divided. Like, for example, uh, let me just share the screen to better help the viewers. I would like to have the team, I would like to have the pie chart slide with us. Yes, I will just jump onto this slide. Yeah. So as mentioned, like the processes like RTM and VRTM are basically used for larger part manufacturing, and the resin infused and pultrusion are the current markets that are adapting the sensing systems the most. Uh, this pie chart indicates the processes that are used in composite manufacturing at right now. And basically, resin infused is used across all these industries, like we can see aerospace, automotive, wind energy, and other composite industries like construction, electronics, and electrical, like that. So, with this overview, I would like to ask about how your products, Nikos, how your products are helping these industries with better intelligence and sensing systems.
Well, the idea is to have sensors in the mold. Perhaps we can go through this in my presentation. I can
Sure.
show you what kind of sensors we are using and some indicative applications of this technology. If I can have my presentation, please. Yeah,
Yes.
thank you. And I can go through the technologies that we are using, and then with some applications, and at the end I will have a few slides about the two innovation awards that you have mentioned in the beginning. Uh, so yeah, we are working globally all around the world with either with universities and research centers, but also with several OEMs, large OEMs across the composite industry, like wind energy and aerospace. More and more, we are working with aerospace companies, and I would like to add here that more and more we are working also with, for example, with more advanced processes like autoclave curing.
Okay.
This is an ongoing trend that we have seen recently. Uh, our technology is an advanced version of dielectric monitoring. We are using what we call it DC-based dielectric monitoring, and actually is being the conductivity, the resistivity is being measured, and from that resistivity we can define the state of the resin. That means that we can define on the fly the viscosity. We can define the gelation. We can define the ongoing TG, or degree of cure. This is this is this is achieved also by having sensors in the mold and in the part, durable sensors and disposable sensors. And we have also a system that can only it's more special for RTM and infusion, as you have mentioned, and it's more about defining the resin arrival at specific locations, having again similar sensing systems like durable and disposable. Recently, we have also launched the Cure Simulator, which is a system that can use without having sensors, cure sensors in the mold, by just getting the temperature from the mold and replicating the cure monitoring away from the mold. I will explain this later. Also,
Sure.
we have further developed communication systems, software that can communicate with PLC, for example, or other automation systems, and can transfer our data to the central PLC.
Okay.
As you can understand, we have done several validations of our technology. For example, here I have placed some graphs from the National Composite Center about viscosity, and from a wind blade application with carbon rotec, showing the good accuracy of the online TG and online viscosity that we can provide with our sensors. Advantages can be the same across the composite manufacturing to reduce curing time. This is just a slide showing the advantages for wind turbine blade production, but you can generalize straightforward. To reduce curing time, to ensure part quality during production, to check resin quality, to reduce filling time, and last but not least, to reduce process development time and optimizing the process before going to production.
Okay.
These are some pictures from one of the early applications that we have done in wind energy. This is from Carbon Rotec at 2017. And since then we have advanced a lot. We have been working with Nordex, for example, and uh, and recently we have been working a lot with Vestas in order to develop these sensing solutions and take them to production.
Okay.
This is another application where we monitor the curing of the adhesive in the assembly of a wind blade.
Okay.
And this is for a realistic application of the assembly, having into the process also the cure simulators, which help us by just getting the temperature from the mold from production to replicate the curing. Another application for infusion, as you have mentioned, in a wind blade, in wind cell, with the same idea to provide online the TG. And this one is one where we get the temperature from the PLC conveying to our system and returning back the on in real time the TG and the degree of cure either of the resin or the adhesive. Last but not least, of course, everyone is interested about the business case, and we have seen in several occasions that the return of investment is quite fast, uh, probably less than 1 year or 6 months, even. So there is a very big benefit behind using our sensors in production. So as you have mentioned, we have received where we were finalists in two innovation awards in GEC. One is our participation and our work in the Turbo project, European funded project together with Siemens Gamesa, and where we have developed and placed, installed our sensors in one of their trial molds, and we have proven the effect of our sensors, the benefits of our sensors. And the other one that was 2 years ago, we were finalists in an innovation award in aerospace, together with our partner Safran
Yeah.
in France, and we have proven the same similar technologies and installing sensors in an RTM mold during aerospace, the production of an aerospace part. You can see here some pictures of the sensors and the mold, and some of the results that we have managed to achieve. Especially at the end, we have tried the isothermal injection and curing, which is
Mhm.
quite advanced in order to reduce the cycle time. So
Okay.
you don't need to heat the mold in order to cure the part, but you just inject and cure at the same temperature, which is quite revolutionary for aerospace applications. In automotive is perhaps standard, but in aerospace it's something that they are starting to to develop.
Okay. Okay. Yeah. So that's a lot of direct industry view was really a great example to help me understand the views and all. So simply, I can say that that is fascinating, especially how solutions like OptiMold and OptiCure are addressing very real and long-standing issues in composite manufacturing, like blind spots, void, curing instability, and whatnot. So it has been addressing issues of the long-standing issues, and which, and you also covered like the business perspective, but I would really like to talk more about from a business perspective. The initial investment seems a bit high and is often considered a major consideration for any business. So how these systems justify their cost, like what kind of measurable ROI and operational impact can manufacturer expect from or after the implementation of sensing systems?
That's a good question. We are being confronted with this question for constantly, because it's as I said, our focus is the industry, and that we are trying to help them understand the benefits of our technology. That's why, for example, we what we can offer is not buying but renting our sensors in order to start realizing the benefits, to start seeing the results that they can get to their process. And this seems that it's working very well, because initially, as you can understand, industrialists are quite I wouldn't say that they don't want to do it, but they want to be sure that they can get some benefits for this. So if they are going to spend money, they need to get some benefit. And and this is in relation to what is missing is the whole environment for technologies like this, because as you know, composite manufacturing is quite traditional. They are using traditional technologies, traditional ways to produce. So it's not only the cost of our equipment; it's also the investment from the industry side, in order to uh, adopt this technology, in order to apply this technology in their processes. So it's perhaps cost. I would say the cost of the equipment is, I wouldn't say it's marginal, but it's one of the costs that the industry needs to invest in order to get the benefits of this technology. For example, another cost is the modification of molds, modification of
Mhm.
processes. As I
Yeah.
said, for example, you need to install some cure sensors in the mold. That means that you need to modify the molds in some way.
Yes.
That's why we have developed the cure simulator, in order uh, to help manufacturers um, get the benefits of our technology without modifying a lot their processes. They're modifying, for example, they don't need to modify the autoclave. They don't need to modify large molds like in wind blades. So that can help them a lot. And last but not least is the cost of having this equipment, and the cost of, for example, of training of people to be acquainted with this technology. So there are several costs that we are trying to address in some way, and to reduce them. So make, for example, manufacturers uh, introduce start using our technology faster and easier.
Yeah, that seems very practical way to look at it, especially where in such an industry the initial capex is high, uh, is already high. So as you point out, the while the upfront cost is already there, and the long-term gains of reduce scrap and cycles will definitely impact the future ahead. And the consistency is the factor, like using it, early adoption will definitely help it grow better and wiser. So
Hmm.
it really, it's a shift from reactive to predictive kind of thing. So as you mentioned about adoption, like just to have a view about adoption, let me just get on a slide about the composite market overall, so that we can help our viewers understand how has been the penetration of the market. uh, yeah, so we have this slide. So the composites are growing strong, we all know that. And the graph on the right above side says about the market trends and forecast. Like in 2020, we had 13.9 million tons of composite material market, which is estimated to be around 16.2 million by 2025. And we are expecting a 3.5 ish growth in coming years, with that we'll be reaching 20 million tons by 2031. So the manufacturing will definitely be there of composite, and integration and adoption of this technology is going to be beneficial growing with those industries. So just to have better insights, I would like to add upon the composite graphs. Like the global market was estimated at 16.2 million tons, and the major industries involved in this material are electrical and electronics, construction, transportation. They actually cover the two-thirds of the market. And the graph on the left bottom side indicates the growth. That are the CAGRs of the industries that are very much keen and very prime in case of adopting the sensing systems. As Nikosh mentioned, that is their major market. After that, he mentioned about the Siemens program, which is a wind energy program. We will definitely see construction based penetration and sensing systems in coming days. Uh, I do have an example of that. Like in one of the colder regions in North America, we had this one sensor system which detects the road temperature and everything, so that the trucks passing by will have a better uh, way or a better conditions to approach to the thing. Electrical and electronics that includes the PCB, the printed circuit boards, that are a very niche market according to us. And we believe these are the very much prime focus for sensing system adaptation in coming years. So the penetration definitely of composite material as a whole in these industries are rising. The need of high performance material across these industries is very vital. And as mentioned in the intro, the process, the years of focusing on materials have gone. Now it's more about how intelligently we make, right? So it is quite important to use and adapt sensing systems along with AI. So as mentioned about AI, we will definitely talk about AI as we have mentioned in our posters and everything, that how is AI going to adapt, how AI is going to be a part of composite manufacturing. So my question for you goes around AI adoption. Before asking you a question, I would just like to help viewers with some of the slides that we have prepared for AI in composites. We have published a white paper on AI in composites. I'll ask my team to just have that with us on the screen. And also I would like to ask our viewers to please feel free to post your questions, your queries, and all the queries do you have regarding the topic to us on the LinkedIn chat. I request to all the viewers to do so. And post that, I would like to also add that this paper, the white paper on AI in composites, is free to have. You can get it free, but just by signing up on the composites website. So coming on to the AI in composite. slide. So AI is there in composite manufacturing for now. We have met a lot of industry experts. We have heard a lot of from them, and the adoption that we are expecting in the composite manufacturing with AI is majorly upon the inspection and testing part right now. But in the recent times, not only inspection, we have predictive maintenance as well. Both of them are the prime focus for AI right now. As the graph says, within a year, we'll be having focus on RFID and vision-based monitorings, ply layup optimization, and most importantly, simulation and design of manufacturability. That is a very important aspect of AI. That is going to be helpful for the composite manufacturing. In fact, do you agree with this, Mr. Nikos? Are we gonna see simulation and design of manufacturability with AI integrated?
For sure, AI is a very important tool towards improving manufacturing. That's a fact. I mean, we cannot argue with that. The
Yes.
question is how we can build our tools to take advantage of AI in the best way. Because, for example, the Turbo project has been developing AI tools for controlling the casting of the blades for Siemens Gamesa. But the question is how you can integrate them in such a way that AI can help to improve the process, because AI, as it is, and this is our experience in the recent years, AI needs a lot of data. And as you know, with in composites, data from manufacturing are very limited. So it's very important to find ways like introducing, for example, our sensing systems in order to enrich the AI with data, with useful data that can take advantage and propose and provide solutions. One way to enrich data for AI is simulations. This is, let's say, the easy way to get a lot of data. But the problem with simulations, as you know, is that simulations in manufacturing are not so easy to be accurate. It's not very easy to be representative of the process. So I would say the combination of simulations and sensing systems can lead to more reliable data that AI can use in order to provide either real time or offline solutions to improve the manufacturing processes in composites always. I don't
That's a very
speak about other other applications like polymer processing in general. Or
Okay. Okay. So that is a very compelling way to a very compelling direction, especially the combination of the real time thing with AI insights is very compelling. But ultimately, sensors provide the data. So the designing part, as mentioned, but is very tough. So we have that in our timelines. It would be achieved or it would be under implementation or in testing phases within 1 to 3 years, which is a very important point. And talking about AI adoption, Mr. Nikos, I recently discovered that one of our key contributors on this white paper on AI in composite, Mr. Jamie Snudden from Pliable. Yeah, so I just discovered that synthesites and pliable are in a partnership, and you 4 days or 5 days ago you posted out a LinkedIn post saying that You are very glad to have the partnership with the Pliable. Tell us something about that, Mr. Nikos.
Indeed, we are working with Pliable. Not quite recently, we have started working with them because they have found, and we have found that we have complementary technologies that could be used to by the composite manufacturers in order to speed up their molding design and processes, and speed up also the adoption of our sensing systems in their manufacturing processes. So we have found that we can provide together a lot of advantages to composite manufacturers. This is for the moment is mainly in the UK, but we would be glad to let's say extend this collaboration worldwide through their web site, and through their AI tools that they have been developing. Actually, we are also in the process of submitting a research proposal in order together with some large industrial players in the UK, in order to further develop and actually demonstrate these capabilities to the aerospace community in the UK and
Okay.
beyond.
So that is a good news for the AI people, the people that we had tune us for AI information. So, Nikos, we have 5 questions from the audience. We can have some of the question, like 1 or 2 questions, team.
Hmm.
So Nitin Gupta has asked a question like, "Hi, Dr. Panteleris. I have a question regarding the cure monitoring technique. How does OptiCure slash OptiMold is different than DEA 288 ionic from NITST with regards to monitoring degree of curation?"
Um, Thank you, Nitin. That's a very good question because we are from time to time we are confronted with this question. Actually, as I said, our technology is let's say an advanced version of dielectric cure monitoring, and we are using DC instead of AC, which is being used by more conventional dielectric systems like the DA system from NETS. In our case, we are measuring only our equipment is measuring only the resistivity of the resin, which is actually the what is being called by more conventional dielectric systems ionic viscosity. It's the same thing, and actually, for example, the NETS system is they are using almost entirely the ionic viscosity for monitoring the cure. In our case, we have, I mean, besides the let's say the electrical measuring, we have advanced much further in order to relate this resistivity together with temperature, to relate it to the TG and the degree of cure of the resin. So our system can provide in real time during curing in situ. It can provide degree of cure and TG as I presented in I saw in my slides, and this is something that we have proven and validated in different applications, not only in the laboratory but also in production. And our systems are being used, for example, in everyday production of wind blades without the need of any further improvement in the monitoring. So with respect to that DEA system, we our system can measure much better and much lower in conductivity and higher in resistivity, and that's why we can use our systems in wind energy, which is more um, it's more difficult to measure than, for example, aerospace, where temperatures are much higher and resistivity or is much lower and conductivity is much higher than wind energy. So for me, wind energy is the most demanding application for our systems. I
Okay.
hope that I have.
Yeah, I guess Mr. Nitin Gupta would be satisfied with his answer. The second question we have is from Mariana Rojas. Very interesting. How easier is to positioning the centers? How much intrusive they are? They are. How many do you need in a blade? I guess in a wind blade, as suggest her display picture.
That's a very good question. Thank you. So, in order to make it's it's not so difficult to position the sensors in the mold, as long as they are durable sensors. Where, but you need, as I said, you need to modify the molds. We have developed for wind blade applications. We have developed these vacuum bag sensors, which can be placed on top of the vacuum bag. These are durable sensors, but still you need to install them each time through the vacuum bag. So I wouldn't say that they are very easy to use, especially in production. You can use it in development, but in production is perhaps out of question. Then they are these are not so intrusive. All these sensors, they are not so intrusive, but you still need to modify the mold, and that's why we developed the Cure simulator. So with the Cure simulator, you what we have achieved is the to transfer the monitoring from the mold uh, away from the mold. And this is done by providing, for example, by coupling by using the same temperature from the mold, from the process, from a specific location, from a thermocouple, for example, and then the temperature is being followed by the Q simulator. And the Q simulator has a resin sample each time, different ones, so we can deal with the batch to batch variation of the resin, and we can and the curing can be followed by the cure simulator itself. So you don't need to modify the mold at all. You don't need to do any, or the operators don't need to be involved in this process at all, just to provide the resin sample or adhesive sample. Um, then the so in this way you don't use any you are not intrusive in the process at all. So the operators does not are not involved in this process at all. So you don't have any risks, vacuum bag leakages or modification of the molds. Then how many sensors you need? This is again up to the process design. That means that, for example, in wind blades, even if you have long blades like more than 100 meters long, we are working, for example, with for in the production of offshore blades, uh, but still you have some lagging locations where the temperature is low, and that means that the curing is low or it's lower than all the other locations. So when you monitor only these locations, that means that if these locations reach the curing level that you need in order to demold or to go to the next phase. That means that all the blade is higher than the target. So in general, we have our experience is that perhaps only 4 locations are enough to define the control strategies for the next phase.
Okay, okay.
So
That
this
that's
has mainly has to do with the expected temperature variations. For example, in aerospace, you don't have um, much variations because you normally produce in an RTM tool or in an autoclave. But in wind energy, there are large variations across the part. So you only need to focus on the areas that they are lagging temperature, heating, and curing. So it's much easier and possible to still use our sensors in wind energy.
the, that's that is very fascinating to hear that only four sensors over 100-meter blade. That is a very big thing, I guess. And adding on to that point, the Global Wind Energy Council is gonna be releasing its report about that. Last time I recall it, the longest blade size was 150-meter. So, Nikos, do you think that four sensors would be sufficient for that as well?
It is a fact. I don't. It's not what I think or what I hope. It's a fact. We have a customer that is using that only in 4 locations. But of course, these are 4 critical locations, as I said. It's not that the other locations are not being monitored, but you are using our systems in the critical locations. And speaking about critical locations, we need to think perhaps more. The industry needs to think more about the monitoring of the assembly, because, for example, in the bonding of the cells, for the moment, it's only the temperature that is being measured, and most of the times not at the critical areas, which is the middle of the bond line.
Okay,
So I think there is a whole area which is being perhaps under valued, under is not has not attracted a lot of attention, but is very critical for the bonding of the blade, and that's why our systems can offer really the information that is needed really at the really critical areas of that process.
yeah, got it, got it. Yeah. So I thank Nitin Gupta and Mariana Rojas for their questions. Thank you very much for your participation. And we have three more questions from the audience, but I insist on going with the planned question first, Nikos. So the next question that I had is about your company synthesites, like perspective. How do you see your technology involving in or over the next decade? We would love to know whether you are betting on any newer territories, including processes or application or technology, or are we gonna see synthesites into structural health monitoring?
Drawal, I think your voice is cut, so I just heard uh, your last part of the question.
So
Uh,
yeah, I actually was
uh,
asking you like, where do you see synthesites in next 10 years? Will you be discovering new territories like structural health monitoring?
we don't want to expand more in the sensing applications for example for services or for usage. We would like to expand more and extend our technologies more towards manufacturing still. We think that we have a lot of things to offer there, and what we have seen is that it takes really long time for manufacturers to adapt our technology. So we need a lot of effort to convince and to help them to introduce our technologies in their manufacturing lines. So we think that in this area, of course, together, as you mentioned, with the AI, with the adoption of AI and the introduction of AI, together with our sensing systems, will lead to a big benefit to manufacturing companies. What also is very interesting is that there's not much competition in this area, in the sensing systems for manufacturing, and this is quite
Okay.
impressive, quite interesting. But so we would like to explore more, to exploit more our technologies in manufacturing and not anywhere else.
Okay. That is itself a very great node at the value chain of composites, surely. Uh, so, Nikos, as we have more questions from the audience, I would just like to have my last planned question. We can just chat with the audience and ask them what they want to hear more. So, uh, after it's a kind of a good. It will be very nice to hear something spicy or something very catchy. Like after success at GC World platform, what can we expect next from Synthesites? Like, are there any upcoming innovation or projects you are excited about?
We do, as I said, we have started working quite recently in autoclave curing. And
Okay.
this is quite interesting and challenging area for us because autoclave curing is considered a very traditional and very conventional area, and
Yes.
it's not. Although it's something, it's very it's widespread, especially in aerospace.
Yes. Yeah.
For until now, we could not prove that we can really offer uh, good solutions to this manufacturing area. And we have recently started working with a large OEM in this area, and we are developing solutions that we are looking forward to be applied in aerospace manufacturing. Perhaps not in the very short term. It's not aerospace is not like wind energy where if they see that there is a big advantage, the innovations can be really applied directly to even to production. Aerospace needs much more time, but we have several um, customers that they are interested to bring our sensing technology in production in the future. So we are really looking forward to that.
Sure. I guess the answer that lied under the verse that you spoke was within 11 months we will see Nikos getting an award on March 4th, like that. Yeah, I heard it. I can sense the words that you said.
Yeah, what is not so easy for, especially for advertisement and innovation awards is private projects. It's
Definitely.
very
Yeah.
difficult to advertise results from there, and that's why you've seen that we were finalists in the innovation awards only for funded projects where we are allowed to advertise our results. So for us, it's not so easy because we would like to advertise more our projects, but it's not possible because of private projects. So it's not so easy to apply recent in the next months for a new innovation award, I would say.
Okay, got
But you
that.
never know.
Okay, so we'll definitely know next year, I guess.
Yeah.
Okay, so we have time for the questions from the audience. I would ask team to bring on the questions. Yeah, so Khalid Labidi asked, what are the sensors based on optical fiber or so? And can they be used in damage detection in laminate composite during manufacturing?
So the sensors are, as I said, dielectric sensors. So nothing to do with optical fibers. They are much more robust. We have been involved in a research project where there were also optical fibers, and it was really challenging to have them in a real manufacturing environment. And our sensors, unfortunately, it's only for monitoring the manufacturing, the resin state, and not the fiber or the laminate state during production. So it's only about the transformation of the resin, the polymerization of the resin, and not of the laminate.
Okay. So the optical fiber, we've discussed this last year, because when I was conducting a study and I contacted you regarding that. So you mentioned that the challenges with optical sensors are the it distorts the mold. It actually affects the surface of the composite with the that even that thin hair fibers. Yeah. So thank you, Khalid, for your question. We can move on to the next question, team. Dr. Neha asks, "Hi doc, how can this be utilized for filament winding process using slit tape for space application?"
That's interesting. We have one customer, and we are working in an application for filament winding. That customer is interested about monitoring the curing during curing in the oven of hydrogen pressure vessel with carbon fiber and epoxy. So perhaps this application is not far from that. We are using some special temperature sensors in order to measure the temperature, and again we have involved the cure simulator in order to replicate the curing with the feedback from these special sensors in the oven of the wound vessel. So it is possible, but it's not so straightforward as the other applications in aerospace or wind energy, in fusion or RTM.
Okay, I guess that answers Dr. Neha's question. A follow-up question on this, Nikos. Like, have you worked with Type 5 pressure vessels? Like, have synthesites provided uh, the sensing systems to any of the players? Like, if you could share this.
For hydrogen pressure vessels,
Yeah,
you
or
mean?
Type 5 pressure vessels, linerless pressure vessels, Type 5 pressure vessels.
I'm not sure about the type of the pressure vessel that this company is working on, but the idea is to provide to provide the cure monitoring during the curing of the pressure vessel. So I guess it doesn't matter so much which type of pressure vessel it is, but it's
Okay.
more if it is in the oven, like filament and wound and spinning in the oven for curing.
Okay, okay, got that. Actually, I just connected the space application with Type 5 just to have a clarity on
Mm.
that. So I guess we thank you, Dr. Neha, for your question. We can move to the next question. Parsuram has asked us in small batch UAV composite manufacturing use it vacuum bagging or resin infusion, where voids, dry spots, and cure variability are common risk. Which in-process sensing methods are realistically affordable and most effective for reducing scrap? While I guess there is more question here.
Oh, it's just a question mark.
Oh yeah.
So I would say that for sure you need to monitor the temperature in several locations because what we have seen, for example, in simple ovens and not autoclaves, is that temperature variability could be a big factor for generating cure-induced defects. And for for small bats, it's to use our sensing systems. But what we have seen is that by using a cure simulator and an optimold in the laboratory, you can get a lot of information about the curing of prepregs, about the curing of resins without having the need for DSC or more, let's say, more scientific analysis. So just the Q simulator and optimal, you can get a lot of information by trying different curing cycles or even replicating a cure cycle from a recorded temperature from a previous trial.
Okay. So I guess this Mr. Parshuram's question. We have a question from which is if we were talking about intelligent materials or intelligent components through integration of sensors, do you think that at some point we will have a lot of sensors integrated into component? And in that case, what is your comment on? I guess the question is partial on the screen. Team, if you could help me with what is your comment on impact on integrity is the full question, Nikos.
I think it's a good question, but not for our sensors because our sensors mostly are used during manufacturing, not during service. But it's a good point that these sensors could affect also the structural integrity, and that's why in most of the cases, for example, when we discuss, because also as I said, we have also disposable sensors that our customers can use, and these sensors can be left in the part. But the problem is that all these sensors are considered by composite manufacturers are like foreign objects, and that's why it's very there's a lot of discussion on what is tolerable and to use in components or parts, composite parts that are going to be used in service, especially in aerospace.
Hello, I guess disconnected. Yeah, am I audible? Am I
There's
audible?
one last.
Sorry, I got disconnected. Yeah.
Yes.
Yes, we can. I guess you have answered the Mr. Roy's question, and I got disconnected in between. We can move ahead with the last question from the audience, and if anybody apart from the people that have shared the questions have any doubts, any queries, please feel free to connect with me, Dhaval or Mr. Nikos Pantelelis via LinkedIn. We'll definitely help you with any queries of yours. So moving on to our last question, Nikos, uh, we have this question from Weber Pandit. From a long-term perspective, how do you see your technology evolving over the next decade? Would We would love to know whether you are betting on any newer territories, including processes and application for your technology.
I think we are trying to cover as much as possible all the manufacturing processes in composites. The only challenge for the moment we have seen is pultrusion,
Okay.
because the profile is moving, and it's not so easy
Yes.
to measure the electrical properties of the profile as it's moving. So the only challenge for the moment is pultrusion, but we see also that there's not much market need for that. So that's why we don't consider it as an area that we would like to explore further. Other applications, for example, we would like to make our technologies more friendlier for in order to increase the market that
Okay.
our sensing technologies are referred to, because for the moment we are working mainly with large OEMs in wind energy and in aerospace, but we would like to expand our market in, let's say, smaller scale manufacturers,
Okay.
and that's why we need to, let's say, to make our technology friendlier and easier for them to adapt it.
Yeah.
We
Yeah.
have tried a little bit to introduce our technology, for example, in India, but we have found several obstacles, mainly due to the problems that I mentioned. But so what we would like in the next years is to expand in new markets, in new countries, and this is much more than expanding to new technology applications, for example.
Okay. Okay. So I guess that answers Mr. Vaibhav's question. Thank you, Vaibhav Pandit, for your question, and thank you, Aniket Roy, for your question. So I guess we are at the end of this discussion. We are about to finish our in conversation Stratview webinar this time, and with that, I would like to thank you, Nikos. Thank you for your insights and time. Hope you had a good.
Thank you, Dorval. Thank you for Stratview to arrange all this very interesting discussion, and I look forward to an update for our discussion, perhaps next year with our new innovation award reward.
Yeah. So as we come to end to this session, I would like to take a moment and express my sincere gratitude to each and every one of you for your time, attention, and active participation. Also to everyone who joined us today. Whether you are an industry insider, a potential investor, or simply a curious mind about composites, we hope this session gave you valuable takeaways. So before we wrap up, I would encourage you to follow Stratview Research and Composites for more such insights and updates. And if you found this session valuable, do share the post with your network. Meanwhile, we keep track of our LinkedIn page to get notified in future, as we hope to host such webinars for you all. Thank you all. Thank you so much for your time.
Thank you. Thank you. Bye bye.